So I'm going to be recording this lecture for 6.4. It's just going to be me by myself. I've got to record this last year with my students, and this year I'm just doing it on my own, so there's no student interaction here. So hopefully it'll go a lot faster and will perhaps be more understandable. So we're going to be dealing with some important concepts about vectors and doing some arithmetic on vectors. The first concept I want to do is called dot products, okay? So to quickly review the difference between a scalar and a vector, so you should know that a scalar is a mere number. Okay, like for example, speed. Okay, and when you talk about speed, you say, you know, oh, I was driving at, say, 50 miles per hour. Okay, a vector has two quantities defining it. So it has a magnitude, and again, this is a review. Magnitude and direction. Okay, and an example of this would be velocity. Okay, so when pilots fly, they don't tell somebody that, hey, I was flying at 500 miles per hour. They typically say that I was flying at 500 miles per hour on a bearing of 210 degrees. Okay, so velocity needs two quantities to define it. It needs a magnitude and it needs a direction. Okay, right, so let's go on with a dot product. So a dot product is really a type of vector multiplication. Okay, we don't do vector, so we've already done vector addition and subtraction. Today we're going to do vector multiplication. And there is really no concept of vector division. Okay. So what's a dot product? I'll start out by giving you an example of two vectors, u and v, defined in component form there. Then this is called a dot product. Okay, it's read as u dot v. Okay, u dot v. And all it takes is simple arithmetic. All you need to do is multiply the x components of the two vectors, the y component of the two vectors, and adding them. So here you can see negative 2 times 5, and you see 3 times 4 right there. Okay, so that's the product of the x components and the y components, and you add them together, and you get a 2. Now notice that the result is now just a scalar. It's just a scalar. It's not a vector where you've got two things in it or two components in it. Okay, so a dot product of a vector multiplication is always a scalar. Okay, a mere number. All right, so here's the general rule for it. Okay, here's the general rule for it. So given two vectors in component form as u dot 1 comma u dot 2, and v equals v dot 1 comma v2. And the dot product is just the product of the the x components and the y components. So here's another example. Okay. Normally in class, this example would have been done by the students, so you can see what's going on there. Okay, or at least I know what whether you've understood or not. So in this case here, again, following this rule, you're going to times this and this, oops, this and that, and you're going to times this and this. Okay, so for the first one, you're going to get a 7 plus, and the second one, you're going to get an 18. So your answer is 25. Again, a mere number. Okay, mere number, a scalar. All right, some more examples coming up. So how do you find the dot vector of I times j, or I dot j? And notice that I'm giving you a hint there that write I and j in component form. So you know that I is equal to 1 comma 0, and you can make this a vector, and you know that j is going to be equal to 0 comma 1. So you should remember from previous notation that your I vector is out here along the x-axis and your j vector is along the y-axis. And so if you do the dot product of this, you times this and this, and you times this and this, and add the answers, and you get a 0. So what's interesting is to notice that, I hope I'm recording. Okay, I have no idea why this came up. So notice that these two vectors are at right angles and their dot product turns out to be 0. So that's an interesting conclusion. If two vectors are at right angles, and right angles is also called orthogonal. Orthogonal. Okay? So if two vectors are orthogonal to each other, their dot product is 0. Okay. Doing the next example, you know that I is going to be equal to 1, 0. Negative I is going to be negative 1, 0. It will be in the opposite direction. So what do we have here in terms of pictures? Okay, here's my I vector. See up to there. It's my I. Okay, and my j is in the opposite direction. Okay, it's in the minus j. Sorry, not j, but minus I is in the opposite direction. Okay, same magnitude. So here's my j. Okay, I'm busy right now. So then, if I do the dot product of this, I'm going to get this times this plus this times this, which gives me a negative 1. So notice that these two vectors are either parallel or they are in the opposite direction. They're actually in the opposite direction. So in some sense, you can say that they are parallel. So if they are parallel, or in the, actually, let's be more specific. If the dot product is negative 1, then the vectors are in opposite direction. Okay, they are in opposite direction. What you might want to do is you might want to try an I dot I and see what you get for an answer there. Okay, so these will be two vectors that are in the same direction. Okay. Okay, here are properties of dot products. Okay, properties of dot products, and these are fairly similar to what you've done in algebra and arithmetic. So, for example, here, dot product is commutative. In other words, if you multiply u dot v, it's the same as v dot u. Here's a zero property, the zero product property of a dot vector. In other words, the zero vector times another vector will always give you a 0. Here's a distributive property, so you can distribute the vectors there. And here's a constant property where you can pull in the c to either the u or to the v. Okay, so these are properties that you've learned in algebra. This obviously is something new. So here it is find the magnitude squared. Okay, magnitude squared is equal to the dot product of the vector itself. Okay, so v dot v is equal to magnitude squared. And if you only want the magnitude, then obviously you need to take the square root. Okay. All right. Next example. Okay. Doing dot products on vectors, but there's some other arithmetic involved in here as well for vectors. So now notice that this says u dot 2 times v. So we could bring the 2 out and then just do u dot v. So we don't have to change the vectors u and v. Just take the 2 out as a constant, do the dot product of u and v, and we know how to do that. It's going to be this times this plus this times this. So that's going to be negative 2 minus 12 gives me negative 28. Okay. And to do this, notice that this is going to be a scalar, which we are then going to multiply the vector w with, so our result in this case is going to be a vector. So u dot v is equal to minus 14 from here. Okay, so it's going to be minus 14 times 1 comma negative 2, and if you write it in component form, it becomes minus 14 comma 28. Okay, so doing some dot products. Again, to emphasize, notice that this result is a vector. because what we end up getting really is a scalar here times a vector, which gives us a vector. Okay. Okay, last formula of the day is the angle between two vectors. So here's your formula. It just reads cosine theta is equal to u dot v over the magnitude of u times the magnitude of v. Okay, so straight out formula to find an angle between two vectors. And the application of this. Oops, that's not what I meant to do. I will have to go resurrect that. Where are we? Okay, so we are finding the angle between two vectors. So the formula is cosine theta equals u dot v over the magnitude of u times the magnitude of v. So here's an example. Okay, so the angle between these two vectors, cosine theta, is equal to u dot v. So u dot v is -2, that's this times this, plus 3, which is this times this, over the magnitude of u. So remember, the magnitude of u is going to be square root of -1 squared plus -1 squared times the magnitude of v, which is going to be the square root of 4 plus 9. So this gives me 1 over square root of, let's see, that's 13 and that's 2, that's square root of 26. So this becomes root 26 over 26, and then to get the angle you'd have to go theta equals cosine inverse root 26 over 26, and you know how to plug and chug this on your calculator. Okay, and make sure your calculator is in degree mode, because typically when you talk about angle between vectors or angles in a triangle, you're talking in terms of degrees rather than radians. Okay, so that's the formula for angle between two vectors. Find the angle between I and j, and we've kind of done this before, but we'll do it in a different way. We're going to do it based on the formula for the angle between two vectors. So remember, I is going to be equal to 1, 0, j is 0, 1. The angle is given by cosine theta is equal to u dot v, which is 0, over the magnitude of I, which is 1, times the magnitude of j, which is 1. So that's cosine theta equals 0, and you should know that theta is equal to 90 degrees in this case. Okay. Again, when vectors are orthogonal, i.e. at right angles, okay, the dot product is 0. Okay, and remember, this is a friendly angle. Okay, this is a friendly angle. Alright, the next one is the angle between u and negative u. So let's do this in a very formal way. Okay, we're going to call this u1, u2. Oops, let me erase this and write it neatly. You have u1, u2. So then minus u is going to be negative u1, negative u2. Okay, you just reverse the signs of each one of the components. So then cosine theta is going to be the dot product, so it's going to be minus u1 squared, this times this, plus or minus u2 squared, this times this, all over the magnitude of u. Okay, and the magnitude of u is going to be square root of u1 squared plus u2 squared. Magnitude of v is going to be, remember this is v, okay, I'm kind of going ahead of myself here, that's like a v. So the magnitude of that guy is also the same, so u1 squared plus u2 squared. So this gives me minus u1 squared plus u2 squared all over u1 squared plus u2 squared. The square roots disappear because you're multiplying by the same thing, and this gives you minus 1. So from your trig, you should know that theta is equal to 180 degrees, okay, which is what we saw earlier as well, that when the vectors are in opposite directions, which is what these are, okay, these are two vectors in the opposite direction, the angle between them is 180 degrees, okay. So if the angle between two of them is 0 degrees, in other words, the vectors are both in the same direction, okay, then theta will turn out to be equal to 0, because cosine of 0 is equal to 1. Oh, I believe that may be the end of the lecture. Let's see. Okay, that's it. Well, I hope you view this. Bye.